yeah, welcome again to the final in this series of OrcaFlex 11.1 user group meetings. Probably many of you will have attended the meetings earlier in the week. So welcome back, and also welcome to, if this is your first one, welcome in. My name is David Heffernan. I'm in charge of software development at Orcaina, and helping me out today are Colin Lewis and James Pell, two of our senior software developers. And as you know, we would normally run these meetings in person, but the pandemic has meant we're online, and we would normally run the meetings towards the end of the year, in this case 2020 last year, but we've been delayed. We delayed because the OrcaFlex release itself was delayed, and because we're online, we've been able to time the meetings to happen around the time of the release. So the OrcaFlex release itself was delayed because of just the huge amount of effort that went into getting the restarts feature ready. And because we've been delayed, we're actually planning to get back on track with our normal sort of annual release schedule, trying to release towards the end of the year. So I would expect 11.2, or planning to get 11.2 out around October, November this year. Because it will have, by necessity now, a shorter development cycle, I think it'll be a much less ambitious release than 11.1. So don't be surprised if you don't see as many new features in 11.2 as there have been in 11.1. That should be obvious. Now, if anyone has any questions, and I'm sure lots of you have been here before and are familiar with this, so this is going to be tedious for you. But for any newcomers, please ask them in the Zoom Q&A. And what we'll try to do is that if questions we think that they would be worth sharing with everybody, we'll save them to the end and then answer them live, and then everybody can hear the answer. But alternatively, sometimes it may be that one of James or Colin will answer the question in text. So I guess what I'm saying is if you ask a question and don't get an answer immediately, don't worry about it. We will pick them all up at the end. We will be publishing recordings of the sessions on our website next week. If any of your colleagues or even yourself have missed some of the sessions and want to attend, then look out for those appearing. If you're even more desperate, then you can still actually register for the webinars, and then you will be able to watch them on demand. So if you missed one of the early ones in the last couple of days, just go back to our website, register again, or register for the webinar, and then you'll be taken straight through to watching on demand. Right, this session is about the new features in 11.1, other than in OrcaFlex 11.1 rather, because we did OrcaWave yesterday. The new features in OrcaFlex 11.1 that aren't restarts and the features related to restarts. So that's what we talked about a couple of days ago. So the functionality here is of much smaller changes to the program than restarts itself, which was a really huge new feature. But there's quite a few interesting and useful features, and sometimes the small things, particularly when taken together and sort of seen as a whole, can actually make quite a difference. So hopefully everybody will find something here that will be useful to them. And as I always do, I point out the documentation can be found for each release, help, what's new, and we have the lists of new features with hyperlinks through to the details of the change. So I'll just be giving a high-level overview. If you need to learn more about any of these new features, come to the documentation, go to What's New, and follow the appropriate link. Right. So I'm going to be flitting through from one feature to the next. And to begin with, I'm going to talk about turbines. And turbines, I've just dropped one on the form, and I'm going to show node axes, and I'm just going to put a few more, put a few more segments in there. So the change that I want to talk about is prebend, which is something that you can now specify for a turbine. On the structure page of the data form, and I will keep doing this. I'll try and get both my turbine and the data form on screen. I can put in a value. I can do really crazy things like that, which I mean, realistically, it's going to be smaller, isn't it? And curvature in prebend curvature in X and Y, and I've obviously grossly over-specified these curvature values just to demonstrate it. So it's on the face of it, it's a very, very simple feature. The data is certainly simple to enter, even if it might sometimes be tricky to get hold of the actual numbers. It's a feature that matches something you can already do with OrcaFlex lines, which are very similar to turbine blades. But it's actually an important feature, even if it looks like quite a small change. The prebend can have a pretty significant impact on turbine response. So being able to model it now is important. Let me have a look now at a pre-prepared example. And I'm going to show range graphs for turbine blades. Now, range graphs are the existing feature. Previously, you could only have them for lines, but turbine blades are very similar to lines. And a range graph plots a variable, plots how it varies across the arc length of a line, or now in the case of a turbine blade, a blade. So I've selected the turbine here. I'm going to look at results for tension and bend moment. For blade number 1, you can specify whichever blade you want, and obviously you just get the results that are defined for blades rather than the whole turbine itself. And it takes a little while to extract the results, and here we have range graphs for turbine blades. Now, I mean, previously this information was available. You could get time histories and do min and max at a particular arc length, but what you couldn't do is this nice plotting of the whole thing across the whole blade. And the final thing to mention about turbines, we've done a bit of work on our examples. We added a new turbine example which is available on our website. And this includes a model of the NREL 15 megawatt reference turbine, particularly notable because it uses the NREL reference open source controller Roscoe. That example had a fixed foundation, a fixed bottom, but we are in the process of slightly reorganizing our examples. So the fixed turbine fixed platform will be changed from the 15 megawatt to a 10 megawatt, and we'll add a new example with a floating platform for the 15 megawatt turbine. So we think that's maybe a little bit more representative and a little bit more useful. So keep an eye out for that coming to our website fairly soon. We have also updated the turbine controller examples to support the Roscoe controller, and when we release 11.1b in the next week or two, we're going to update these controller examples even further including support for individual pitch control. And you can get the turbine controller examples from our website if you search for that phrase, OrcaFlex turbine controller examples, and I'm sure you'll be able to find that. But you can actually even pull them out of the help file. They're actually embedded in the help file. So if I go to is it blade data, a guide to using Python external functions, I click on that and I get to download a zip file with all these examples in case you didn't know where to find it. Okay, I'm now going to leave turbines behind and talk about lines. They've not had that many changes because, I mean, lines are a pretty mature object in OrcaFlex. I'm going to look at bending stiffness, and bending stiffness has a variety of ways in which it can be specified. It can be specified as a linear value, or using the variable data option, we can define it as, I'm not going to put any values in here, but you can define it as a non-linear function, a bend moment against curvature. That non-linear function can be elastic or hysteretic. And you can even define bend stiffness as being specified by an external function. For axial stiffness and for torsional stiffness, previously you had similar options, but you only had linear or non-linear elastic. Well, now both of them can specify the stiffness as an external function, so that's new. And additionally, if you're specifying it as a non-linear, with a non-linear table, you can opt for that table to be interpreted in a hysteretic way. Select hysteretic, and we're gonna model it using our classic hysteresis model. I won't demonstrate it now, but that is also available for torsional stiffness. The other change that we have relates to contact diameter. If you notice now, there's both outer and inner diameter. Previously, there was just one contact diameter, and it was the outer contact diameter. If you leave these values at tilde, they pick up the values from the diameter value specified here, but you can override them if you want to use a different diameter for contact purposes. And we've added it's not, most of the contact models are contact at the outer surface, but for line contact, it is possible to have contact at the inner surface of a line. So because we've done that, that's available, we had some users that, for whom it would be beneficial to be able to specify the inner contact diameter being different from the diameter specified here. We have added a couple of new result variables for lines. I'll just point them out in the documentation. You can find out the definitions by looking yourself. Sidewall pressure and total mean axial strain. And the final thing I want to mention is, I'm going to go back to OrcaFlex 11.0 for this. Let me see. Yeah. The last few releases, it's been possible to have the line reset representation accounting for the seabed using the analytic itinerary solver in OrcaFlex. And there's been, in 11.0, there were two ways of working with this. You could either define a user preference so that would allow different users to have a different preference, whether using the analytic itinerary representation or whether they use the quick representation, or as opposed to a per user setting, there is a per model setting that's built into the data file where you can choose to say, like, this data file will always use quick or will always use analytic catenary. Alternatively, the default was let the user decide on an overall preference and apply that preference to any model which is set according to preference. Well, I won't explain why, because I tried to do that this morning and got myself tied in knots because it's quite convoluted. But for various reasons, we've decided to remove that preference. So now the setting, whether or not you represent the line in reset with analytic, catenary or quick, that setting cannot be controlled by user preference. It is always determined by the model data. Okay, so it's maybe it's a slight loss of convenience. I'm not even sure how often that convenience was used, because I suspect most people just have it on analytic catenary the whole time and don't think about it. So I suspect nobody will really notice. But if any of you were reliant on that, I'm afraid it's gone. The preference anyway has gone. The feature, the functionality is still available, but the user preference mode has gone. But there were very good reasons for doing that. Right. We'll look at vessels now. A couple of changes in that setting. Again, they're quite a mature object, so there's not a whole lot that's different. Yeah. So frequency dependent added mass and damping. In previous versions, you specify the data added mass and damping matrices at a range of periods or a range of frequencies depending what convention you're using, and those were finite periods or frequencies. But the program actually needs, for the convolution integral, the program needs an infinite frequency added mass. And previously the program would estimate that using the data provided for finite frequencies. But diffraction packages are capable of calculating the infinite frequency added mass matrix, and OrcaWave does that, and a number of others do that. And once we'd got to the stage where OrcaWave was producing it and outputting it, we felt it was a bit odd that we weren't using it in OrcaFlex. So you can now use that in OrcaFlex. It's pretty simple to see how it works. I'm actually going to import a model from yesterday's OrcaWave presentation. I'm importing that OrcaWave results file into OrcaFlex itself. I've got hydrodynamic data calculated by OrcaWave, and we can see that we have an infinite frequency added mass matrix defined. And we will import that from other sources. If you're importing from WAMIT and the WAMIT output file has it, then it will come in to OrcaFlex. Likewise for generic text files. At the moment, we can't import it from Aqua because, so far as we know, Aqua doesn't export that information. We may be wrong here, but we've found that whenever we've tried to ask for collaboration with Aqua on our import facility, we don't get any response from them. So it may be that you users that are also Aqua users may know differently and may be able to tell us that actually you can get this information out of an Aqua file. If that's the case, let us know and we'll see if we can bring it in. But otherwise, there are other sources, the other programs, and certainly OrcaWave, which I think a lot of people are starting to use now, produces it, and we will import it. And I just also wanted just to note that the previous method is actually looks pretty reasonable. It depends on your data, but I'm going to show the graph of added mass here. The green dotted line is the infinite frequency. This has come directly from the data, so that value 205 corresponds to that value there. If I happen to delete this, and you might have such a data yourself in even in OrcaFlex 11.1, OrcaFlex will revert to estimating the data from estimating the infinite frequency value from the finite data. And if I look at what that is, zoom in. Previously, the calculated value was 205. The estimated value 217. It's a little bit out, but it's it's the same ballpark. So I don't think what was happening previously was too far off the mark, but I think it's an improvement to use the accurate calculated value if it's available. The other change with vessels is relates to in the calculation options. This data is new in 11.1. The options of how you calculate hydrostatic stiffness angles. It is only used when the calculation mode is filtering. It's not a data item that you get offered when you're using QTF modifications. But when you're using filtering, then you have to choose between orientation and subtraction. Subtraction was how the program did it previously. And what this controls is how OrcaFlex calculates the rolling pitch angles used as input to the hydrostatic stiffness load. And so long as the vessel type's datum trim angle is 0, then these two methods are equivalent. It doesn't matter which you choose. But when that's not the case, when you have non-zero datum trim angle, then there is a difference. And for significantly non-zero datum trim, we believe that the orientation method is preferable. So, for any future models that you build, you should use orientation, which is the default. And we've retained subtraction just so that you can compare, like for like and recapture previous calculations. We've made changes in the past where we've forced a change of calculation on users and regretted it vis-a-vis QTF modifications. So I think sometimes it's nice to retain the option of doing the old method, even if we don't believe it's the best way of doing it. It does at least mean you can compare and see what the difference is readily. Now, I'm going to move on. As I said, I'm flitting around from topic to topic. I'm going to move on and talk about wave time histories. And anyone who's used these, I would imagine, has experienced some pretty painfully slow simulations. And the reason for this is that when we use time histories for wave elevation, they are implemented using Fourier transform, which generates wave components. Now, the number of wave components generated that way increases as the duration of the simulation increases. And if you have a long simulation, then you can end up with a large number of wave components, and that in turn can mean it's very expensive to calculate fluid kinematics. This issue with longer simulations leading to larger wave components and slower simulations only really applies to wave time histories. Other time histories in the program, vessel motion, wind speed, constraint, imposed motion, etc. Those are using spline interpolation, and there's just no comparable issue to deal with there. So it's specific to wave time histories, this issue. And I'm going to look at a prepared example. I have a simulation duration of 10,800 seconds, which is 3 hours. And my wave data, it's a time history. And, we've got 0.1 second time interval. It's all pretty routine stuff. If I run this and wait to see the first estimate of the time taken to run a 3-hour simulation, it's a pretty simple line. There's only 100 or so elements. If I look at them, it's not a single line. It's not a big model, but it's going to take over a day to run this analysis. And the reason is, if I come back into the environment form and look at the wave components, then I see I'm dealing with 65,000 wave components. It's a lot of wave components. And the way we've suggested you deal with that in the past is if I scroll down, if I select the amplitude data, it's low to begin with. Fairly rapidly, as frequency increases, we get some significant values. And then again, the absolute lion's share of this table has very, very small amplitude. And it turns out that you can often neglect huge numbers, the majority of the components, without actually losing any really important information. All those high frequency components are there to ensure that the wave just goes through each data point exactly. But to get the overall sense of the wave, you don't actually need them. So we've been suggesting you find some way of truncating, taking the first so many lowest frequency wave components, dropping them in as user specified components, and that's it. Gives a significant speed up. That's fiddly to do if you've got lots of different time histories, etc. It can be awkward. So what you can now do in 11.1 is you can get the program to do that process of truncating the high frequency components. Get the program to do that for you, and you can control it by specifying a truncation threshold. We will remove high frequency components up to a specified percentage of the overall spectral energy. So what I'm saying here is I want to remove high frequency components, but I want to remove no more than 1% of the overall spectral energy. Now if I look at the wave components again, I can see that whereas previously, well, the total number before I've truncated them was 65,000 still, but now I've only got 4,000 left. So I've got more than 10 times fewer wave components as I had previously. And if I run the simulation, I should find that it's a lot faster than it was. It should be more than 10 times faster. So what was formerly over 24 hours is now under 2 hours. And that feature, in combination with wave calculation optimization methods, perhaps a kinematics cutoff depth for a deep water case, and some of the various options you have here, combine those, and you can get some significant speed ups. Now it's also worth pointing out you don't want to take too much off, because if you take too much off, you're going to lose you're going to lose accuracy. So you should do sensitivity studies to determine whether or not it's okay to take 1% off. If I change that to 0.1%, then I'll find that whereas before I had 4,000, now I've got 6,500 components. Probably isn't going to be that much difference in the runtime. Maybe you're more comfortable with 0.1. Maybe you're prepared to bite a bit more off. You need to work out yourself where to draw the line in this. Now we're going to move on and talk about objects with zero mass, which is a new thing in 11.1. So objects with mass, vessels, buoys, lines, turbines. In previous versions, you could not set the mass to zero. OrcaFlex would object. But now in 11.1 you can. And this tends to be useful when you're connecting objects together. You might have a series of 60 buoys all connected together, and maybe you have one parent object, which is your sort of maybe your frame of reference object, maybe you might think of it. But you connect a bunch of other objects as children to it, and you give them all the mass, the loading, and so on. And maybe you want to have no properties on the frame reference object. And previously, if you were doing that, you'd use this give buoy negligible properties option. And when we did this, lots of data is all zeroized. And previously, the mass would be set to I think 1e minus 3. I think I'm remembering that correctly, but it wouldn't ever be set to 0 because the program would not allow you to perform an analysis with that. And it doesn't let you perform an analysis with that because the equation of motion is singular if the mass has gone to 0. But now we're allowing you to set the mass to 0, and I'm going to show what happens if I run this case. I've got no statics, so I'm just going to jump straight into dynamics because I don't want to mess around with trying to find a static equilibrium for this buoy. I just want this buoy to drop under gravity, and I've got 0 mass for it, and I'm expecting this to fail because of exactly what I said. The equation of motions are singular. And that's exactly what happens. The simulation is immediately unstable because we've got 0 mass. But in reality, the scenario I talked about, you would have objects connected to this one. So now my other example has the same, all the same data, the same buoy, but now I've got this 3D buoy is connected as a child of the 6D buoy. This one, the 3D buoy, has some mass, so the compound object now actually has mass. So that's how I've been able to to run this. Dynamics all works perfectly because the combined structure, the compound structure, actually does have mass, even though one of the objects in it doesn't have mass. So it's not a huge change. I mean, you could always work around it by putting in a very small value, but we felt it was worth allowing you to put in exactly 0, which makes it clearer what you're doing. Otherwise, you might be justifying, why is that value, 1e minus 3? What does that mean? Why have you chosen that value rather than anything else? Let's bring up the help file again, and I will mention some new results for vessels. When you're using frequency domain solver, you can now get results for first order wave load, second order wave drift, and added mass and damping. And let me also flip over to modal analysis. A very small change. I put the model in that I prepared into static state. I'm going to perform a modal analysis with mode shapes, and so long as I have mode shapes reported with respect to global axes, we get this new information. Each mode's modal mass and modal stiffness is reported in the table. Okay, now I'm going to move away from the calculation side of things and start talking about drawing. And as you know, when we introduced OrcaWave in 11.0, we introduced the code, the ability to import panel mesh, which is needed for diffraction. For OrcaFlex, we've used that same code to allow you to import panel mesh data to use for drawing data in OrcaFlex. So there's no calculation based on panel meshes in OrcaFlex itself. That all happens over in OrcaWave. But it can be very useful to import those panel meshes into your typically OrcaFlex vessels. And I'm going to demonstrate this in 11.0 to show how things were, and then show how they've been changed in 11.1. So in 11.0, if I come over to the drawing page and I go to import, I need to change this because I've been, let's see if I can find the file. This is the WIMET example semi-sub, which I know has 2 planes of symmetry. And if I, gosh, I need to specify that it's a GDF file. And if I import that, then yippee, I get my semi-sub, and everything's all wonderful. Let me just hide these things. And I will also note I've imported 4,000 vertices and 8,000 edges, and in fact, although there's symmetry in the panel mesh, I've not retained the symmetry. We've kind of exploded the symmetry at the point at which we did the import. If I switch this to shaded graphics mode, then the result isn't so great, because what happens here is we've not specified a shaded graphics model, and so OrcaFlex takes the wireframe data and finds convex holes for all the connected vertices. All these vertices are connected together, so we end up getting the convex hole, or the smallest convex shape that contains these vertices, and that's really just not what you wanted. So in 11.0 you had a separate step. You had to go to the shaded drawing file, and you could go and then select the same file, specify my symmetry options, and there you go. So you can do it in 11.0, but it took a few extra steps. And the thing that we realized was that for the shaded drawing, what you want is you want panels. You actually want triangles. And these panel mesh files contain either triangles or quads. Well, quads can easily be split into triangles. So why are we importing panels, quads or triangles, converting them into edges and then doing the convex hull when we could just retain the panels and use them directly? So that's what we've done in 11.1. Now, if I do the same set of operations, which I'm going to have to go and do the same hunting around for my files. Now when I come to import, I've got this new option. Do I want to import as edges or panels? Now, almost always you should import as panels. We've only retained edges in case you want to import and then share the file with someone who has an older version of OrcaFlex that doesn't understand panels. So if I import as panels, then well, I can see I'm actually getting fewer smaller data. Previously I had 4,000 vertices, now I've got 1,000. That's because we've retained the symmetry information, and we've also imported as panels and retained the panel information. It looks exactly the same in the wireframe, of course, but if I now switch to the shaded, then immediately we have the drawing that we want. We did not need to set any data here in the shaded drawing. We didn't need to repeat ourselves. And now, in fact, this file is completely self-contained in terms of drawing. I get the nice panel drawing, and all the data is inside the OrcaFlex model. And because we've retained the symmetry information, we're able to store less data. There's less storage required because we've got fewer vertices. In order for symmetry to make any sense, the planes of symmetry may not line up exactly with the body origin, so we also have wireframe origin to support that symmetry. Now, the other change relating to drawing is for the convex hull algorithm. So if you've got a wireframe that doesn't come from a panel mesh and you don't have panel data, we will still use convex hull to generate the drawing for shaded. And one thing that we found when users were able to import panel meshes is that they had wireframe data with a lot more, that was a lot bigger than we were used to. And this is an example where we've got 34,000 edges, which is a lot of edges, 17,000 vertices, and that's the thing that counts for the convex hull. Our previous code, which was a homegrown implementation of the convex hull algorithm, was not as efficient as it could be, and if in 11.0 were I to click on this button, which I'm not going to do because it's fairly disastrous, the program sits for minutes trying to work this out, literally 5 or 10 minutes to work it out. Click on that here, it's instant. That's because we've replaced that convex hull code with a more optimized version. And moving on to my final topic, which is embedded scripts. Now, OrcaFlex has the ability to use embedded Python scripts for external functions, post-calculation actions, user-defined results, and curvilinear constraints. It's been able to do that for some time. Curvilinear constraints, the Python code you use is already embedded in the OrcaFlex data. But for the other three options, external functions, post-calc actions, user-defined results, the Python code is held in an external file. And sometimes this can be a little inconvenient because you have to move the files around together, and if you forget to do that, you have a sim file without the associated script. It can fail to load. So what you can now do, and I've loaded up our classic heave compensated winch example, which uses a PID winch control, PID controller implemented as a Python external function. And this now uses, in this new data here, where we have an embedded script. The old way of doing it is still available. You can specify it as an external file. But if you use an embedded script, then the text, the actual script, is contained in this rather tiny window. I don't expect anyone to type in and do sort of keyhole editing in this. That would just be ridiculous. If you want to do the editing in OrcaFlex, see this button here, which will open up a pop-out editor. We have a very, very basic editor embedded in OrcaFlex now. You can show special characters and line numbers, and you can do code folding, and there's find and replace. But it's very basic. And before anyone starts asking for more advanced features, like regular expression searches or macros or anything like that, we're not going to implement an advanced text editor in OrcaFlex. There's a lot of really good text editors around. I mean, a huge number, and everyone will have their own preference. So if you want to do more advanced stuff, then do that in an external text editor. Really, this is just so you can see it easily with a bit of syntax highlighting, and maybe make the odd small change. Now, the other places where we have embedded Python, post-calc actions, the same is true, embedded or external. When you're embedded, you get the pop-out editor, and very similar for user-defined results, embedded or external. Now, embedded has some advantages, but still external is useful. There's times when maybe you have many models, multiple load cases, say, and they all use the same script. It can be repetitive to embed it in every single model. Maybe you want to make a change just to that one script. You'd have to go and apply that change to all of those models. We sometimes share code between different external functions in one file, in one script. The canonical example of that is the turbine controller, our Python turbine controller, which implements in one script a torque controller and a pitch controller. If you use embedded for that, then you end up with two copies of the same script, which is kind of wasteful. External script allows you to use revision control. So, there's pros and cons to each way, and it's up to you to decide which you prefer. Okay, and that's the end of the presentation that that we have prepared. I'm going to stop my screen share in a minute and close up and deal with any questions. Yeah, when the meeting's over, we are going to you will get from Zoom an email with a URL for some feedback. This is one thing that we can't do quite so easily as when we're in person, is with extracting feedback. So we really hope that you'll be able to fill in that feedback form. I'm actually going to post the URL in chat. So if you want to do it straight away, in chat I've got the link there. If you fill in that online form, we'll get that feedback. We really appreciate any suggestions that people have for future developments. Always, if possible, try to give some context when you suggest some features, so we can understand why it might be useful. And also, we'd like to hear feedback on how these series of webinars have gone. So what we'll do now is myself, James and Colin will try to deal with any questions that are still outstanding. And if any of you have any more questions to ask, then we'll stay so long as there are more questions, as long as it takes. Okay. The first question: when I attempt to open a model generated in a previous version, I get an error message: include seabed friction in statics not recognized. This happens because your model is a YAML file, and in fact, I'm just going to do a screen share again, just to show something about this. So this is actually we have in our what's new. We have a piece of text talking about this with compatibility issues, and particularly referring to text data files. We don't attempt to maintain compatibility from version to version. There's good reasons for that. It's actually whilst we can retain compatibility with a binary data file quite effectively, we really can't do it anywhere near as effectively for text data file. So there's the convert text data file utility. It's all documented here in the program itself. It's under Tools, Convert Text Data Files. And if you have text data files prepared in one version, this tool will allow you to bring them forward into the new version. And it does it by reading it in the old version, saving it as binary, loading in binary in the new version, and then saving as text also in the new version. But really, for compatibility across versions, the binary data file is what you need to use. Any update on the frequency domain feature? Well, you've seen what's been. I've presented what's new this time, but I think we're still getting around to prioritizing what features we are going to do in the next release. I suspect there will be some effort on frequency domain, but we also have quite a narrow window of time to do developments. We have quite a few ideas of things we want to do with the frequency domain feature in the future, and it will come, if not in 11.2, then in a later version. And if you've got any suggestions, then let us know in the feedback. Possible to have embedded MATLAB interface without passing through Python? I don't think that'll ever happen. It is something that I could imagine being possible, but it would be a lot of effort, and we can do it already in Python. So that's just something where I think you're going to have to do that, do those embedded scripts in Python rather than MATLAB. It's just much more effective, and I think we have any plans at all to embed MATLAB in the way we've embedded Python. Any plans to extend the 2 million point limit in 3D seabed? I think the program struggles when you go much above that. I think it's already close to the limit. Yeah. Although, I've not looked at that recently. So maybe if you want to pursue that and you want to persuade me otherwise, maybe you can send me some realistic data that has more than 2 million points, and I'll see how it works if I remove that limit and increase that limit. I'd be prepared to give that a go. And if it turns out maybe 64-bit and maybe modern computers are more able to handle it, then we would happily extend it. But I have a feeling that it gets the program starts struggling with that. But yeah, you convinced me otherwise. Ideally with an example data file, and I'd be very happy to change that. Okay, I've now cleared all of the open questions. So if anyone has any more. Is there any chance of recording analysis videos showing more than one 3D view window at the same time? You can do that with third-party software. I would do it with. I mean, there's tools. What is it? What is the one that we sometimes use? Camtasia is one. I mean, I would do it with OBS or Open Broadcast Studio, but that's only because my son happens to be a video streaming gaming geek, and that's how he taught me how to do it. But there's lots of tools out there that allow you to record screens, and I think it's more effective to use them rather than us build them in. We'd rather devote our resources to other areas and let you use third-party tools that do the job already. I'm just scanning through the questions that were answered in text. Okay. Right. Well, this is your last chance for this round of user group meetings. If you want to ask a question, your last chance to get one of us to answer it live. I've taken all the questions live, and you've not seen James or Colin yet. They are here, but if you ask a question that's too hard for me, I'll pass over to one of them so they feel they've done something useful. We have a question: are there any plans for a seabed model includes nonlinear friction to allow modelling of breakout re-embedment? Yes, that's on our quite high on our list of things we'd like to do. And I don't know when that'll be. I would hope we could do something on that for the next release. That feature, better, more advanced lateral seabed modelling, I think can fit quite nicely with restarts in particular. So that's something that I would hope would come. We have a question that I'm just going to ignore, and I'll pick it up with the asker outside the meeting, who is being cheeky, which is fine. Vertical. So, are there plans to include vertical bearing load capacity for soil models? Can I just? Is that maybe James? You might be familiar with this. Is that TZ curves that we've talked about, or maybe the asker could confirm? Am I right in thinking what you mean by that is what we refer to sometimes as TZ curves?
Yeah, I mean, it sounds like it. I think. Let's pop it on the feedback form and elaborate a little bit with a bit more detail. But it's certainly something that we've talked about many times in the past.
Okay, thank you. Colin, do you want to pick this one up?
Somebody asks why. only half of the matrices, by which we actually mean the top right corner of the added mass and damping matrices are imported from Aqua. OrcaFlex insists on receiving symmetric added mass and damping matrices. So we take, the top right corner of an added mass and damping matrix, and we use those values across the diagonal to get both pieces symmetrical. In terms of insisting on symmetry in OrcaFlex, ever since we developed OrcaWave, at some point in the future, we would like to implement diffraction analysis for bodies forward speed. That's one of the easiest ways to break the assumed symmetry of an added mass and damping matrix for a vessel. So if we ever do get to that point of doing forward speed diffraction analysis, we will have to change OrcaFlex to match, to accept a non-symmetrical added mass and damping matrix. But for now, we're still limited to symmetric matrices, so we take the top right.
Thanks, Colin. See, I'm glad you've all asked questions that have meant that Colin and James have proved to be useful. That's actually one of the benefits of doing these meetings online, is that we can get the right people here, and I think hopefully you've all appreciated having the sort of developers that know the stuff, able to answer the questions on the spot. Yeah. Pal, do you want to pick this one up?
Well, I don't know the answer as to whether we're going to include it as a do. I know that, I mean, this came up as part of...
Could you read the question out?
Yeah, sorry, good point. So the question is our development listed to have winch inertia calculated with the implicit solver? Related to this, is winch acceleration considered to be added as a result? Yeah, I mean, this came up, we touched on this actually with the restarts testing quite recently. And when I spoke to James Carlisle, who's another developer here who's sort of in charge of the solver engine, it's apparently not trivial for us to have it in the implicit solver. That's the reason it's not there, and I don't think there's been huge demand for it. But it is theoretically possible. So if people request it, then it will certainly be considered. As for the result, the explicit only result, I imagine again that is. I don't see why that's not possible, and I mean, I would imagine it would be fairly trivial to add. So I think again, put it down on your feedback form to remind us of it, and we can review that. I mean, it could be there's a good reason it's not added as a result, a technical reason, but I suspect not. So yeah, thanks.
Yeah, I mean, often things aren't in the program because we've never thought of adding them, and then other times things aren't in the program because they're incredibly hard to do, and possibly we have one of each in that last question. And if you ask for either, then we'll do our best. But obviously, if you ask for something that's easy to do and it fits well, then that tends to be the kind of thing that just gets done quickly and rapidly. Okay, we're hanging on for any more final questions, but if none appears in the next 20-30 seconds, then I guess we'll wrap it up. And I'll get to dismantle my webinar studio. It's been nice the last 3 days being in the office. It's the first time I've worked in the office for an entire year. Which it's been quite nice, although it's also been a shame because I've been here basically with one other person or something, so it's not quite the same as having the whole crew here. But okay, it looks like we got an end to the questions coming, so I will wrap things up here. Thank everybody again for attending. It's been really great to have so many people come along and asking questions and showing enthusiasm and support. And again, it would be great if you can all fill in the feedback forms and reply to that. And we will see you again at some point, quite probably towards the end of the year, and quite possibly by webinar again. But you never know. Okay, thanks everyone, and goodbye.